Hello students, this is our fourth unit. We have seen time estimation. What is actually the time estimation? We have gone through details. What is time estimation? Why time estimation is necessary? What we do while estimating the time? Why it is an important, very much important. There is a very much importance to this particular time estimation in project management. We have seen different types of time estimation methods, and that methods by using historical data, by using different data. Historical data means by using different documents related to uh, the project that were undergone before. The we can estimate the time, means we can calculate the exactly time here. After that, we have seen different methods using historical data, using time tracking software, bottom up method, top up method, expert judgment. All of these things we have gone in detail with each and everything. Today we will go to the next point of this particular project management fourth unit. That point is determination of the critical path. What is actually the meaning of critical path that we have seen? The critical path method we have seen at the starting of this particular chapter, or the particular unit. The critical path method here is a technique where you can identify the tasks and that are very necessary for project completion and determination scheduling the flexibilities. Okay, a critical path is a project management. It is the longest sequence of activity that must be finished on time in order for the entire project to be completed. It means that it is a technique where you can identify the different tasks that are necessary, how that are necessary for the completion of the project, that we will see in critical path method. Okay, this critical path in a project management that refers to the sequences of the tasks that are essential for your project success. Okay, this task that we are performing one by one in sequential manner, whatever that task, that sequence of the different tasks, that is called as a critical path method, and that is actually done in the critical path method or critical path in the project management. It is a longest series of different tasks within the project, and if any of these tasks they are delayed, it will push out your project end to date. Tasks that aren't on the critical path that can be delayed without impacting your overall schedule. The mini scheduling tools that will automatically identify your critical path for you, as long as you build the different key elements into your schedule, that is all project tasks that with start and end dates, task duration, task relationship, and or the different dependencies. Next, we will see how to manually calculate the critical path in the project management. That we will see now, how we can calculate the critical path in the project management. If you are not using the project management software, or just you want to double check the things for yourself, that here are the different manually steps for the calculating the critical path in the project management. Let us see that. First is identifying all your activities or tasks and note their durations and relationships. Building a schedule network diagram, which is a visual sequence of how you task how the different tasks of yours are interrelated, and identifying all the possible paths through the diagram. Okay, and adding up all the task duration to calculate the time to complete each and every path. The path that has the longest total duration is your critical path. Okay, this is how we can calculate manually the critical path by considering different points, by identifying the different activities and tasks and noting their durations. We can find the critical path, building the schedule network diagrams and sequencing the tasks that are interrelated, and by identifying the possible paths through the diagram. That also we can do for the purpose of manually calculating the critical path, or manually getting the critical path in the project management. The benefits of calculating the critical path in the project management are: once you identify your project's critical path, you can quickly understand if a delay will impact the overall project, and it will react accordingly. You can prioritize the different activities on the critical path and schedule less essential tasks to spend out the different resources. That are the different benefits. In short, in the definition, we can say that the critical path method is a technique that allows you to identify the tasks that are necessary for the project completion. Okay, the critical path in project management, that is the longest sequence of activities that must be finished on time for the purpose of completing the entire project. Now we will see some of the steps for that, how you can find the critical path of the any project. Building out a project roadmap that can help you to visualize what needs to be done to reach the particular end of the goal. The critical path method that will help you to exactly do the same thing. It's a project management technique that involves mapping out the key tasks or critical tasks that are necessary to complete a particular project. Leveraging this particular technique allows you to manage the task dependencies and set realistic time frames. Now, let us go in detail with the CPM, that is critical path method. What is actually the critical path method and why we are using the critical path method in project management? The CPM here is a technique where you identify the tasks that are necessary for the project completion and determine the schedule flexibilities also. A critical path in the project management is the longest sequence of activity that must be finished on time in order for the entire project to be completed. Okay, any details in the critical task that will delay the rest of the project. CPM here revolves around discovering the most important task in the project timeline, that's identifying the task dependencies and calculating the task durations. CPM that was developed in late 1950s as a method for the purpose of resolving the issues of increased cost due to the insufficient scheduling. Since then, the CPM has become the popular for planning project and prioritizing the task. It helps you to break down the complex projects into the individual task and gain a better understanding of the project's flexibility. Let us see why we use the critical path method. CPM that can provide a valuable insight on how to plan the project, allocate the resources, and schedule different tasks. Let us see some of the reason why we should use this method. This particular CPM method improves the future planning. CPM can be used to compare the expectations with the actual progress. The data that is used from current project that can inform the future project plans also. It will facilitate more effective resource management, and CPM helps the project managers to prioritize the different tasks, giving them a better idea of how and where to deploy the different resources. This critical path helps to avoid the bottlenecks also. Bottlenecks in a project that can result in lost valuable time. Plotting out the project dependencies using a network diagram that will give you a better idea of which activities that can and that can't run in a parallel, allowing you to schedule different accordingly related to the project. Getting it? Why the critical path method is necessary? These were some of the reasons. Now let us see how to find the critical path method, CPM. Finding CPM that will involve looking at the duration of the critical and not critical tasks. Let us see some of the steps for the purpose of getting the information about how to find the critical path. While finding the critical path, the first step that you have to do is you have to list different activities. Okay, use a work breakdown structure to list all the project activities or tasks that are required to produce a deliverables. The list of activities in the work breakdown structure that serves as the foundation for the rest of the CPM. Okay, that is how it is important to list the different activities in a particular project management for the purpose of creating the critical path method. For example, let us see, let's say a marketing team that is producing a new interactive blog post. Some of the tasks that might be in the work breakdown structure, that is, so the different task we have to define here is first task, let us say the task ID is A and that task is creating the outline. Okay, duration of the task, let us see 1 day. Next to that, let's consider second task. We can call it as a task ID as a B. We will write the draft. Okay, writing the draft for that particular project or producing the that particular blog. It will need 5 days of duration. Next to that, consider task C, editing and creating the final draft. That will need the 2 days. It is only editing and creating the final draft. Actually, we have created the draft in 5 days. We have to simply edit and make different changes in that, and we have to make it a final draft. It will need the 2 days. Next, task D, that will designing the post visuals. After making a draft, we can make the different visuals after we will post that. that will need consider 4 days. Task id consider e on the next step, that is adding animations to the visuals, it will need the 2 days of duration. Next task, consider task id as f, it will need uploading the post and it will need 1 day. Once you have a high level idea of everything that needs to be done, you can start identifying the task dependencies also. This is how you can create a critical path method here, or critical path duration here, by using this CPM. Okay, in this first type, or the first step, we have just enlisted the different activities. We have defined how much time is needed for that particular activities, and what are the different activities that is to be done over that particular days or particular tasks. Okay, and we have given different ids to the different tasks, that is nothing but the listing the activity. That was the first step here. The second step we can consider is identifying the dependencies. Based on the work breakdown structure, determine the tasks that are dependent on one another. It will also help you to identify any work that can be done in a parallel with other tasks. Okay, let us see some of the task dependencies based on the example that we have seen now about making a blog or posting the blog by creating that blog. Task B, that is dependent on A. What was the task B? That was writing the draft. Okay, these were the tasks that we have seen now. Task A, that is creating outline, it was duration 1 day, then writing the draft, then editing and creating the final draft, then designing the post visuals, adding the animations to visuals, and uploading the post that we have seen now. Here task B, that is dependent on the task A, writing the draft is dependent on creating the outline. Task C, that is dependent on B, because we are editing and creating the final draft. For that we need the actually written draft that was done in the B. After task C and D, that can run in parallel. C is editing and creating the final draft, and D is designing the post visuals. Both can be run in parallel. Okay, we can on one side we can create a that particular edit and create the final draft, and we can make the designs for the post visuals. Task E, that is dependent on the D, because adding animations to the visual, that will be ultimately dependent on the designing the post visuals. After we design the post visuals, then only we can add the animations and visuals. Task F, that is dependent on C, D and E. Task F is uploading post. C, D creating final draft, designing the post visuals and adding the animation to the visuals. If we have done all these 3 steps, then and then only we can make or we can upload that particular post. This is how the posts are interdependencies are there in the different steps. In this second type, we have identified the different interdependencies of the tasks. The list of dependent tasks that is referred to as an activity sequence, which will be used for determining the critical path. Okay, getting it, how to identify the different dependencies of the task. The next step here we can consider as creating a network diagram. The next step, that is turning the work breakdown structure into a network diagram, which is a flow chart that is displaying the chronology of the different activities. Okay, it means create a box for each and every task and use different arrows to depict the task dependencies. We can show the different arrows for the dependencies of the different tasks. Okay, you can add the other time bound components for the purpose of network diagram until you have the general project schedule figured out. Okay, this is how network diagram can be created here by the if we identify the different task dependencies, then we can create the network diagram, because in the network diagram we are using the different boxes for the purpose of showing the different tasks. Then by showing the arrows we can check the dependencies of the task. Next, that is for the next step here we can consider is estimating the task duration. To calculate the critical path, the longest sequence of critical tasks, that you first need to estimate the duration of each and every activity. To estimate the duration, you have to try to making the educated guesses based on the experiences and knowledge. You have to you have to make the estimations based on the previous project data. Okay, you have to make the estimates based on the industry standards also. This is how you can estimate the duration of that particular project. Alternatively, you can try using the forward pass and backward pass techniques also. Forward pass, in this is used to calculate early start and early finish also. In forward pass, calculating early start and early finish dates by using the previously spaced dates, okay, start dates. ES is the highest. ES is nothing but the early start, and EF is early finish. ES is the highest and EF value from the immediate predecessors also, where ES and EF, early start and early finish, plus the duration. Okay, that is the duration. The calculation starts with the 0 at the ES of the first activity and it proceeds through the schedule. Determining the different ES and EFs dates allows you for early allocation of resources to the project. Here you can backward pass also. That is used to calculate the latest start and late finish also. Late start and late finish, that is the duration here, with late finish is the lowest than the late start value from immediate successors. The calculations here, we have to start with the least schedule activities and different proceeds backward through the entire schedule. The early and late start and end dates that can then be used to calculate the float or scheduling flexibility of the each and every task. The next method we can consider, or sorry, no, next step is calculating the critical path. Here, after following each and every step, at the end we can find a step for the purpose of calculating the critical path. While calculating the critical path, that can be done manually also, but you can save time by using the critical path algorithm instead of doing it manually. Let us see some of the steps for the purpose of calculating the critical path manually. Step 1, writing down the start and end time that is next to each activity. The first activity that has a start time of 0 and the end time is the duration of the activity. The next activity start time, that is the end time of the previous activity. Okay, we are considering the two activities. The first activity that has start time of 0 means at the time of 0 seconds it is going to start, and end time is the duration of the activity, means whatever the time is needed for the purpose of completing that activity, that is the end time. Okay, let us consider the second activity. The next activity here, that start time of the next second activity, that is end time of the first activity. Okay, when we finish the first activity, then and then only we can start the next activity. And the end time is the start time plus the duration. End time of the second activity, that is start time plus the duration that is needed for the purpose of completing the second activity. This is the end time of the second activity. We will do this for all the activities as we have done for the first, second, third, fourth. Whatever the number of activities are there, we can apply this algorithm for the each and every activity and we can calculate the actual time. Next step we can do is looking at the end time of the last activities in the sequence to determine the durations of the entire sequences. Next step is the sequence of activities with the longest duration, that is the critical path. Okay, using the same example, we can using the same example, using the same steps, we can calculate the critical path in each and every activity or each and every task, and we can understand how that particular critical path is calculated in case of any project management. Whatever the steps we have seen, by using that same step, we can see a critical path diagram just as shown in this diagram. You can say at the starting there is a green mark and a green circle and start. There we are starting in a task. We are going to task A, that is for 3 days. Next is task B, that is for 4 days. After the completion of task B, we are doing the task C. Means task C is completely dependent on task B. When we will complete task A, then and then only we will go to the task D, E and F. By this arrow, you can see how these different tasks, they are interdependent on each other. Okay, at the end, there is a finishing line, means after completion of task C, task A and task F, we are getting exactly the output of the project. The next step here is calculating the float. How to calculate the float, that we will see in this step. Float or slack, that refers to the amount of flexibility of a given task. This indicates that how much the task that can be delayed without any impacting sequent task or the project ended. Finding the float that is useful in gauging how much flexibility the project that you're undergoing is having, how much flexibility it is having. The float, that is a resource that should be used to cover the different project risks, that is unexpected issue that can come up. The critical task here that have zero float, which means that their dates are set. The task with positive float numbers that will belong in the non-critical path, meaning they may be delayed without affecting the project completion date. If you are short on time or resources on critical tasks, that may be skipped. Calculating here the float that can be done with an algorithm, or it can be done manually also using the calculation from the sections. Now let us see how we can determine the float, and it can be free float also. Total float versus free float, sorry, total float versus free float. Let us see the breakdown of the two types of the floats. What is total float and free float? Total float, this is the amount of time that is an activity can be delayed from the early start date without delaying the project finish date or violating a schedule constraints also. The total float here is ls minus es or lf minus ef. Okay, and the free float, it can be referred as, it refers to how much long an activity can be delayed without impacting the different activities. There can be only there can only be a free float when two or more activities that share a common successor on a network diagram. This is where the activity they converge. Free float, that is equal to es into the next task minus ef of the current task. Ef is early finish and es is early start. There are some of the good reasons why the project manager they are benefiting from having a good understanding of the float. That is, it keeps the project running on time, it monitors a project total float, allows you to determine whether the project that is on track or not. Bigger the float, the more it is likely you will be able to finish early it on time. Okay, it will allow you to prioritize, that is, by identifying the activities with the free float, you will have a better idea of which task that should be prioritized and which one have more flexibility to be postponed. It is a useful resource, that is, float is an extra time that can be used to cover a project risk on unexpected issues that come up. Knowing how much the float you have allowed you to choose the most effective ways to using it. These are some of the steps that we have seen now for the purpose of finding the critical path. First, we have seen listing the project task and different details of the project. We can list the different tasks, what are the tasks and what is the duration that is needed for the task to complete. The next step, we have find out the identifying the task dependencies of the project. If the tasks are they are interdependent or not, that is that identification is done in the second step. In the third, we have seen the creating a network diagram of different tasks. That also we have seen, by making the network diagram we can get actually the interdependencies, and we can show, means in the second we can identify the different task dependencies, but by creating the network diagram we can find out the dependencies of the different tasks in a better way. The next step is estimating the each and every task duration. We can find out the duration that is needed for the purpose of completion of each and every task. Next step is finding the critical path, that is based on the longest sequence. That also we have seen how we can find the critical path based on the longest sequence. Whatever the sequence we are following here, that sequence, the longest sequence, the longest task here, depending on that longest task, we can find out the critical path here. And next is calculating the total float. We have seen different two types of float. What are the two types of floats we have seen? Total float and free float. What is the meaning of each and every float? We have gone in detail with that. Here in the last step we are calculating the total float. This is how, these are the steps that we have to follow for the purpose of calculating the critical path here in the project management. Now let us discuss how we can use the critical path method here. The critical path method that provides the visibility in the project progress. It will allow you to monitor the different tasks and their completion times also. We find the time that is needed for the purpose of completing each and every time. Let us see how we can some of the additional applications of the CM that we will see now. Compressing the schedules. Though it is not ideal, there are times when the project deadlines that may be pushed up. In those situations, there are two schedule compression techniques that can be used here: fast tracking and crashing. Fast tracking is looking at the critical path to determine the different activities that can be performed simultaneously, that is running parallel processes that will speed up the overall duration here. And second was crashing, the process that involves allocating the more resources for the purpose of speeding up the activities. Before obtaining more resources, you have to make sure that would be still be within the project scope also, and it should let the stakeholders know how of any changes or not. Having the critical path plotted, one can help that you choose the appropriate strategy to meet the updated deadlines. Okay, this is how we have seen what is actually the meaning of critical path method, how we are what are the different steps that we are using for the purpose of creating the critical path method, calculating the critical path, estimating the time, that we have seen in details. Thank you.